In this laboratory, we're going to use Newton's second law or the momentum principle. But first of all, I will leave you with the video I will analyze and from where I will extract all the data we're going to use to make the computational model. Here, I use Tracker and I upload my video. And I use Tracker to take out the time and the position in the positive x-axis. You can see here all the transition of time and the position in the video of the ball. You can see here the graph how it's going. You can see here all the data of the video. The data we extract from Tracker. Here's the initial time, it's about 0 seconds, and the initial position in the positive x-axis is about 0.001. You can see here that it is the first position, the first x-axis position. And obviously the net force is about 0. To take out the initial velocity or the average velocity, we need to have more data of the video, but what data we're going to use? So we need a second time that is of 0.034, and we need a second position always in the positive x-axis because that's where the ball is moving, and it's about 0.042. To make this, we have to calculate the position 2 subtracted by the position 1 and divided by the time 2 subtracted from the time 1. So here I did it, and the average velocity is of 1.2 meters per second. That's the velocity of the ball. Here I use Python to make the computational model. I replace the vectors. Here I put the first position of the ball and the average velocity, and here the time is of 0. And this I take out the hashtag, I erase it because I use this to make a graph using spreadsheets on Google. And in here I put the last observation time, the last time of the video. I have it here. The last time is of 0.935, so I place it here because that's the last observation time. So having all this, we run the model or the computational model, and this is what we got. You can see here how the graph is going up, and in here how the ball is moving. And I will show you the graph I did in spreadsheets on Google. Here you can see the dotted line represents the experiment position, the blue dotted line, and the orange line represents the model position. As you can see here, the y-axis represents the position and the x-axis represents the time. But we have two questions that we have to analyze, and these are: what if, when you analyze your video data in Tracker, you made a choice of the orientation of the axis? Discuss briefly how your results would change and how they would remain the same if you were to flip the axis. If I flip the axis here in Tracker, so then the position of the ball would be in the negative x-axis. This ball will go to this place, to the negative x-axis, and the time will still remain the same, but the position will be negative. And the second question is, what does it mean? Your observations can be predicted well by your computational model when you set the net force equal to 0 in your model. Is it possible for you to say how many pushes and pulls are added together to give 0 net force in the case that you observe? Discuss briefly. This is like an obvious question because the net force is of 0. So any push or any pull would make the net force 0 because the net force is already of 0. So this is my laboratory.